That was really cool. Definitely nothing to be embarrassed about. Great presentation. And now we have smoke signals. It's an MQP type idea with Professor Batar, Jeffrey, Andrew, and Petra.
Hey, so we all just sort of finished our MQP a little bit later than we were supposed to, which is why we had to come back here and present it. My name's Andrew Cunningham. And this is our MQP. We called it the Autonomously Controlled Modular Low Bandwidth Communication Method utilizing BiCMOS semiconductor manufacturing techniques for applications in swarm robotics and cloud processing through air dielectric capacitive breakdown and computer vision technology applications. I don't know. Well, we were coming up with an acronym for it, but then then we couldn't come up with one. So what we developed was an outline for our presentation, which you can see here. So this is the brief history and background of our research field. It started from a primitive sort of activity where you get your Native Americans and they sort of send sort of smoke signals from one little tribe to the other, which was just sort of stupid and ridiculous. So then they invented the telegraph machine, which was annoying. So we had to move on to telephones, which I don't personally understand, to Ethernet, which nobody understands actually, and then to band networks, which I took a class on and I don't understand that at all. So we had a research gap we were trying to fill. This was it was a big problem. It was such a big problem we called it a P-type research gap, where we needed to identify a much simpler and a lot more robust form of communication that we could all understand more easily than these weird sort of there were big holes in our research field, so we filled them.
Great. So our concept is to apply more modern technological advancements to the simpler, more robust communication methods. So taking the smoke signals and making them 4-bit. So as you can see, you get an answer of 13. So our design overview is quite simple. So we start out with a river. That river goes to a hydroelectric dam. That dam goes to our power source, which goes to a microcontroller. Goes to a bank of capacitors that are 4-bit, where depending on our programming, either explodes or puffins land on them. Now, this is where it gets a bit more complicated. You have a camera on the opposite side of that river, which does image processing to an advanced series of networks of microcontrollers and breadboards, but not that one, to achieve that 13 plus or minus 0.5 depending on the availability of the puffins.
So we did a little bit of a simulation in MATLAB, because you have to use MATLAB for MQPs, I guess. And so we took the MATLAB logo and we overlaid it with a saddle function. And as you can see at the red point over here, we identified that as being the critical point. And you see on the right graph, we use this to compare and contrast different kind of battery chemistries. And then we took a little bit, I guess, a linear regression or something, and we got 9 volts. So, yeah. So going off of that, we decided that we'll probably go with Duracell batteries. And we did a little bit more of a finite element analysis this time, a little bit more advanced. And so we drew up the battery in CAD. We applied a positive force to the positive terminal, and we grounded the other side. And we ran the simulation, and it looked like the color changes throughout the battery. Yeah, what? Yeah. Come on, the commercials say Duracell. You got to use Duracell. So yeah.
Yeah, so we had some unpredicted safety issues with our design, where we were testing them, and you know, a lot of us, because we have great school spirit, we're very enthusiastic about our major, electrical engineering. So we started some fires, and there were some issues. So then we had to address these safety hazards. But on the brighter side of it, we were able to empirically prove that these safety hazards, which seem kind of dangerous, you have fires, aren't as bad as what you get actually with chainsaws. They are more dangerous than the capacitors were, which just is, looking on the bright side.
But we wanted to make advancements in the safety of our project, so we thought, how can we make capacitors and inductors even safer? Could we combine them? Maybe using quantum mechanics or something like that, which everyone wants to, but no one really understands. So we came up with the capaciductor. So it's a revolutionary new circuit element, which will forever change electrical engineering, but not capacitor engineering, unfortunately. And it's quite simple. You take quantum mechanics and add circuit elements, and then you have the capaciductor, as seen below.
All right, so being as this is an entirely new circuit element we just discovered, we're trying to kind of find some expressions we could possibly use to describe it. Maybe the capacitor or the inductor, or maybe even combine them at all. But basically the idea is that you take a superposition of both the electric field and the magnetic field, and this is pictured over here in the top very confusing diagram on the top right. And the oscilloscope capture on the bottom is some kind of waveform that you get out of this element. So in conclusions, we decided that communication is probably best left to the Native Americans as they originally did it, and probably the communications major, since that's in the title of their major, I guess. And we are pretty certain that we'll probably not hurt ourselves or other people with chainsaws, but we are very certain that we will go over budget, and we probably do it right before it's due. Now, we're looking into getting more funding to advance this future of electrical engineering. So we're looking at maybe getting some funding from the NSF, maybe getting a Kickstarter, but you guys in the audience, you can be a part of this too. All it requires is $10, a little bit of your time, send us your picture, we'll put it in our newsletter whenever that gets out, and just be a part of the revolution,
All right, so this was our sponsors, and any questions? Now, it affects our grade if you guys don't ask us questions, so if somebody could pipe up and just sort of ask something very useful and easy. Well, we actually have a process for making the donations. What you do is you go to the National Donation Institute. It's actually in my backyard. And then what we're going to do is we have sort of a solar paneled little slot. You can just dunk coins into it. And then, you can see just in this diagram here how that works. So you identical person right there, do you have any questions? We have encryption methods in our yeah, we do. All right. So we got a good grade, Batar? Yeah.